This video is on piecewise functions. We are going to be writing a piecewise from a graph. What we're going to do is we're going to write the function and domain restriction for each piecewise graph, then state the domain and range of the actual graph. On this first one, we have three pieces of graph. So we have a part of a parabola, part of a line, and then a point. So there are three parts. In the first part, I'm going to focus starting from the left. I'm going to say that this is our first part. This is our first equation. So I'm going to write that in pink. The second one, I'm going to go towards the line. This is going to be our second graph, our second equation. So I'm putting a 2. I'm going to do that in green. Then the third part is that one single point. So I'm going to highlight that, and that's going to be our third part. I'm going to do that in blue. So we can start out writing our restrictions as well. This is going to be the first one. I can put this as f of x. I'm just going to put this as a of x because this is the first example. Is equal to a squiggle, a big squiggle bracket, because I'm going to have all three of these equations in here. So we can start with our restrictions. So with the first one, I'm going to leave some space here. I'm going to put a comma. So I'm going to put my restrictions. My x value, I have one arrow and one point for the x values. That means I will have one inequality. So x, the first x value, or the furthest to the left is the negative infinity. The furthest to the right is that negative 2. So I know it's going to have that negative 2 on it. If it's going towards negative infinity, that's going to be less than or equal, less than negative 2. I'm going to have x is less than negative 2. It is solid there, so it is an equal to. I'm going to go ahead and go to my green, my second one. So here, my first coordinate is at the x value of 2, but then it stops again at this 5. So that's going to be between two parts, but then it starts back over and it goes right forever. What that means is I'm going to have two parts to this because I have two circles, but then I have an arrow. So I actually have all the graph between these two values. So it's between that 2, and then it's also between the 5. So it's going to be the 3, the 4, so it's bigger than the 2, but smaller than the 5. Now, since they're open circles, I cannot put the equality with it. But then I actually start back over. Or, since I have to start back over, it's again at that 5 right there. It's again starting back, but open circle. So it's going to be one circle and then one arrow. So it's going to be x is greater than that 5, because it's going to go off to that positive infinity. So x is greater than 5. Then the last one for the blue, I have it in just one spot. It's a solid circle, so that's going to be an x equals something. There's no arrow, it's just one point, so the x is equal to 5. So on this one, this last one, x is equal to 5. So now let's go with the equations. For the pink one, this is a parabola, so we want to put it into that vertex form. So if I'm looking at these coordinates, pink, my vertex is located here, which looks to be at -4, +7. -4, +7. So when I'm writing my equation, I know that I will have parentheses, x plus 4, because it's x minus h. So x minus the -4 is x plus 4. And then plus 7. But I need to know my a value, because I know it's going to be negative because it's opening down, but I need to know if it's also going to be a 1 or if it's going to be a 2 or something else. So I'm going to put a little bit of math down here. So this is going to be 1, this is part 1. We have the h value is our -4, k value is that 7, but we need an x and a y value. So we also have a coordinate. We can use this coordinate because it's solid there. that -2, 3. So that's at -2, 3. So the x and y we have, so -2 and +3, we need to find our a value. So that's when we do our math of, we know the general form of y equals a parentheses x minus h parentheses squared plus k. So we're plugging them in. We have 3 equals a parentheses -2 minus -4 is +4 parentheses squared plus 7. Go ahead and subtract the 7 over, so it's going to be a -4 equals a parentheses -2 plus 4 is 2 squared. So we'll have -4 is equal to 4a. So a is equal to a -1. So we have our a value of -1. We can just put that in here, -1. So we actually have the equation and the restriction for the pink graph right here. So let's do the equation for the second one. This is a line, so what we need to do is find the slope and the y-intercept. So for the slope, we're starting at, we have this coordinate, so we can go to this coordinate right here. We want to go 1, 2, 3 up, right 1. So we know it's going to be a 3x. Now we have to go the opposite way to find our y-intercept. So if we go down 3, left 1, not the y-intercept yet, down 3, left 1. There's our y-intercept, -10. So it's just 3x minus 10. There's your equation for that one. Since this last one is just one single coordinate, we already have the x value of the coordinate. We need the y value of the coordinate, because this is y equals this number. So we have the x of 5. The y value is -2. So this blue equation would just be y equals -2, but we only want it at x equals 5. These are the equations with the restrictions for this graph. Now we still need to find the domain and range of the entire graph. So domain. We have left arrow, and we also have a right arrow. So the farthest left is an arrow, the farthest right is an arrow. So we will have negative and positive infinities. So we'll start with our negative infinity, and we'll have to see where it has to go. So we want to go to the right. So starting with the arrow, go to the right, 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 stop. So I can't keep going right. I have to go see if there's anything I can jump to up and down. There's nothing I can jump to, so that means that this actually has to stop. So it goes to that x value of -2. And it was a closed bracket. Union. The next place I can start back over at, on the right, so cannot start at -1. There's nothing at 0. There's nothing at 1. There is something at 2, but it's open. So it's going to be open at +2, comma. I'm going to keep going to the right. I hit the right. There's an open circle. I have to stop. Is there anything solid below? Yes, there is something solid. So that solid point is still okay here. So I have something solid here, and I can just jump back up to here and keep going to the right to that arrow. So that open circle, I can actually refill it with this circle, this closed circle, because it is solid. So I don't have to actually break that. So it will go off to that positive infinity now. For the range, lowest point is your arrow, highest point is your arrow. So from the arrow, I know it's going to go from -infinity. So I'm going to go up, 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 up. I can't go any further up, so I want to jump to left or right. I can jump to right to something solid, and it will keep going up, and I'll hit that other arrow. So it'll be that positive infinity. That's your domain and range for this graph, and we wrote the restrictions and the equations for it.